Swayam Prabha. Digital India. Educated India.
Then we can come to this now, classification of these different subsystems that are normally there. So we have seen this gross positioning that is happening there. Okay, so this is a gross tracking that happens, but that is not sufficient. Okay, so if you see the positioning accuracy that we had talked about was about 100 nanometer. And you can imagine, like, no stepper motor drive can produce that kind of a high precision positioning. Okay, whatever, like, fine micro stepping that you will think it can have, simply because of this mechanical. Okay, maybe you think about what prevents, like, the positioning to happen so finely. See, like, even if you have very fine positioning sensors available, would you be able to position, like, by using this kind of a stepper motor, the system, the head or the laser spot on the surface of CD within the accuracy of 100 nanometers? Okay, that's certainly not possible. Okay, so so what we do? Okay, so then there must be some kind of a fine tracking or some kind of a fine motion system that will be there inside the CD. And as we open up, then we'll get more onto that. We'll observe that. Okay, so we should look for now what is a fine tracking or fine positioning system there. Then there needs to be something needs to be getting, like, the laser. See, the CD surface may have some undulations. Okay, small undulations in the range of few microns. Or you may put, like, some kind of a small little scratch on the surface of CD, and still, like, its scratch is almost in microns kind of a dimension, but still that will be harmful for the data to be read on this from the surface. So the surface may have some few microns undulations, and then, like, you need to kind of tightly focus the laser onto the surface from where the data is to be picked up. There must be some some kind of a focusing servo, or it is like a auto-focusing that is happening inside the CD. So there must be some kind of a small fine motion that is given for focusing direction. Then we have seen this tray handling system, tray operation system, and things like that. Okay, now and of course you need to have a CD rotation system here. So this motor should kind of drive the CD to make sure that it rotates in some controlled kind of a fashion. So let's explore a little more now. Now here again another thought that, okay, so all these pauses are where, like, you need to really pause the video and think about yourself. Don't rush through just this lecture. Otherwise, like, you'll miss out on things. See, this thought thinking and keep preparing your mind to get to understand is very, very important part of the process, which I'm giving you the cues, but I mean, if you follow them only, then things will happen. Okay, so please do that. So now let's think of these two subsystems only. This cross positioning system that you have already seen some part of it, and then fine positioning system. Okay, fine tracking. Okay, how can this be possible? So suppose we know now we need that fine kind of a tracking there. How do you suppose you are supposed to do that? How would you think, based on your knowledge so far, what kind of sensors, actuators that you'll use in this system? Okay, so do some thinking. You may say, okay, oh look, this is very fine positioning which is required. I may use piezo actuators which will give you fine positioning. Okay, fine, like, that can be one possibility. How would you kind of set up such kind of a drive? Piezos typically need very high voltage to operate. Okay, do we have such a high voltage operation possibility? Okay, any other kind of a actuator comes to your mind which can do this job? Okay, like that you need to kind of think about, okay, what kind of a way we sense that, okay, what it is really on the on the um, on the track or not on the track. Huh? So say for example, if you put a sensor on the system side here, okay, is that sufficient to kind of get us know that, okay, it is on the track or not on the track, those kind of things. Hmm? Or how do you kind of get a feedback from the CD surface which can tell us that. So many different kind of questions can come here. Okay, so we should kind of, like, based on whatever our knowledge, think about these different kind of questions and list them down, or like think about, okay, what comes to your mind as a thought to give a solution to these different questions that are coming up. Okay, so let's move on. I mean, after your thinking is done, you can move on. Okay, to see further now what we open up and actually check out. Okay, so these questions, we can have, say, sensors, for the sensors, some encoder possibility, or we can use make use of the track on the surface of CD itself to see if we can use that as a sensor. So actuation, what kind of actuation you can have? Okay, so you can have some CD-ROM drives have actually this servo motor possibility. Okay, servo motors they use as actuators. Some others they use stepper motor as actuators. So things like that can be possible for cross positioning. So again, I'm flashing the same picture here. So you can see this is some view from some other CD-ROM drive, and this is from, like, the currently open CD-ROM drive that we are talking about. So this is the same picture as we saw. So do you see any sensors up here for positioning sensing? Okay, so you see that this stepper motor typically will not have any sensors that are needed for sensing the position. Okay, so you observe that, okay, there is only the shaft coming out of the sensor, and there is no sensor up here. See, typically the motor shaft needs to have a sensor, if at all the sensor is there in the system. Okay, so either motor shaft or, like, the slider moving, like, back and forth, needs to have some slide position sensing possibility. But if you observe carefully, that is not there in the system. So there is no sensor in this cross positioning kind of a system, only stepper motor, and we rely on the steps of the stepper motor to make sure the desired position is achieved. And then, of course, actuator is this stepper motor along with this lead screw. And this mechanism, this is a way, is useful for preventing the backlash. You heard this term, backlash? Okay, see, if I have only, like, say for example, only one teeth going into these slots here, then depending upon, like, this is some kind of a manufacturing tolerances and errors, the slot size and my teeth size may not match perfectly. Okay, there will be some kind of a, within some kind of tolerance accuracies, few microns kind of accuracies, it will be not matching it. That means, like, that much kind of a back and forth motion I'll have around in the slot. Okay, so imagine, like, you have a hole in which there is a rod which is smaller in size is pushed, and you can move the rod in the linear direction, any radial linear direction, back and forth in the hole. Okay, that much kind of a, you'll see that kind of a thing is a backlash in the system. Okay, so these clearances that are given typically for, like, smooth motion happening, like, will result into some kind of a backlash in the system. Okay, so this backlash is some problem which in mechanical systems, you think of gears, you'll have a backlash. You think of any kind of, like, these motion transmission systems, they'll have some backlash that is going to be there. And now what we do here is, like, we are using these two stubs here, okay, which are like, pushed against the two opposite surfaces of the screw. Okay, that way, and then the spring is making sure that, okay, that is pushed and that force is maintained, and that takes care of this backlash. Okay, that will not allow the backlash to to come into play. Okay, so that's how this backlash is handled by using this kind of a spring loaded stuff here. Okay, we'll see in other cases, when you have a gear transmission system instead of screw transmission, how do you take care of backlash. Okay, so this is just to focus on this. You have this little kind of a shock absorbing element here. Okay, this is another system, this has this, if you see, this has only two wires coming out of this motor. And then there is a gear system. This is like a bevel gear system, and then there is this gear. Think what is missing in this location A. Okay, so think about that. Okay, what is missing? I have removed something from there. What it should have been, to kind of you can think about, so that the motion from the bevel gear is transmitted to this rack here. And if you observe carefully this area, you see the small little spring sitting there, and this rack is having two parts, the top rack and the bottom rack. Okay, they're exactly same pitch and everything, but they are in the two parts, the top part and the bottom parts are separate there. Okay, so what are they for? So think about that. This spring there, and then top part and bottom part. And what is there in this location A. Okay, think about these issues. This is another kind of a mechanism in which you see the same the spring loaded stuff for the cross positioning system. Now on the guide rails. Okay, so you see this guiding system. So this is I would say one view, and this is opposite side view. Okay, so this is a view from the opposite side than this side. Okay, so say this is head which is seeing the surface. This is a lens which is seeing the surface of a CD, and let me get the pointer properly. Okay, so this is a lens of a CD, and you observe these locations. Okay, these are the locations where the head is touching these rods. Okay, this is one on this side, only one kind of a touch is there. On this side there are two touches are there. Okay, two places it is touching. Now carefully if you observe, okay, then you will find that this touch is happening here on all the sides. As you see here, the rod is covered on all the sides by this hole. Okay, and this hole also. Okay, but on this side there is only one support here, and then that too the rod is not completely covering. Okay, the rod, the support is only covering half side. Okay, that you cannot see here. Actually the cross section view actually will show you that. Okay, maybe where somewhere we have this separately open mechanism, no, this removed from the rod kind of a thing, we'll be able to see that. Okay, but here you presume that you take my words that this is only up to half of a distance. Now you think why this is done in this way. Okay, again I'm not going to kind of give you answer right now. I want you to kind of think about this question, why this construction is happening this way only. Okay, like that you need to have now you can see from the pictures only, but if you have actual drive, you can kind of see this make many of such kind of observations, and then think about and come up with, okay, why that people have done it in that way. Okay, so that is where our nice concepts are going to get developed. Okay, so think about this issue. And you see here in detail now, this again the same thing I'm saying, this is a spring here, and then these two racks are one on the top of each other. Okay, okay, so a lot of things to think about, huh? So how do you kind of like get this spring loaded rack done? What is the purpose here that you think about? So this is like little larger view of the same thing. You can see the spring very clearly here, and then there is a top and bottom rack, and then this top rack is like moving with respect to bottom rack in the direction of this laser pointer. I'm pointing in this direction of motion of the rack. It is they can relatively move with respect to each other. Now let's think about the fine tracking. Okay, what are the requirements, what are the sensors, what are the actuators, and we can open up and talk about that. Okay, so so sensor that is used here is some kind of a photo detector here, and actuator is some small kind of a little voice coil actuator that is sitting up here. So we'll see this as we open up. This will be evident, but now we need to think about how we can create this kind of a closed loop system here, so that you can have a fine tracking and fine focusing that is happening here. What kind of a sensors will be needed, what kind of actuators will be needed for that thing to happen. Okay, so maybe I'll leave you with a small kind of actual observations, and then so we can remove the head from the guide rod and start observing what is there inside the head, means the optical pickup head. We will start looking at. So if you see the head, you'll find there is this block, okay, which is held in the held by these wires, okay, and you see these are the wires up here. Okay, this is a block. Okay, the block has a lens inside it. So the lens moves up and down direction, means this is a focusing kind of a direction. Okay, this block can move up and down. Can this block get stretched front and back in this direction? Think about that. Can this block move sideways in this direction? So there are three directions it can move, or it can tilt. Okay, can this block tilt also? Think about that. So tilting is possible or not, or tilting of this block is possible in any direction. Twisting is possible. So you think about the 6 degrees of freedom any rigid body has, and what are the degrees of freedom this block will be able to move into. Okay, given the constraint that you have these wires which are holding this block here. Okay, these wires are simply some kind of a the small compliant kind of a wires. Okay, as you operate them, you see how so they may not be stretchable, but they certainly are bendable. Okay, so you can see these wires operating actually. Okay, so here can you see that this is a block up here, this is a lens here, and then these wires are connected to this block from inside and coming out here and getting into this small little black portion here. What is there in this black portion? We'll see. We'll think about. Okay, it's very interesting construction done for some purposes. Okay, what is there inside the wire is so it is the wire is not fixed here. There is some small space, and then wire is fixed inside this black part somewhere towards the end. So we'll see why that is done in that way. And if you push the lens down, you can see that okay, this wire is, you can see this wire it goes from here, it goes and comes here. So there are these 3 wires that are used in parallel, and they are getting bent when this block is pushed down and up. Okay, now this pushing down and up action will happen not by somebody moving it up and down, but there are some kind of a coils you can see here, and then there is some magnet that is there. Okay, so the coils are suspended in the magnetic field, and when the current is passed, they'll kind of start doing this kind of a small up and down or some kind of a sidewise motions. Okay, and that is what is kind of important for the fine positioning. Now think why they have put such a kind of a mechanism there. What is this mechanism? How this mechanism is helping us to do the positioning with such a nanometric kind of accuracy. So I would leave you right now at this point, and then we'll discuss things more. So you can see these are coils up here, and then there are these two magnets. Okay, so these two little dots that you see are actually a glue to kind of secure that magnet in position or things like that. Okay, so this is don't worry about this. These two black spots are actually glue, and then you have these coils. The magnets are fixed, and the coil and this lens assembly is actually moving. Okay, so I'll leave you with this right now, and think about now how do you kind of make sense of all these components together, to really think about system which will have this kind of a nano positioning possible. So we'll stop here for this lecture.